In our next example of f of x equals 3 to the power of x plus 1, we're going to use an xy chart to graph this function. Now, the very first one we worked today, where f of x was equal to 3 to the power of x, we used an xy chart to graph that as well. And then we used, for the next two examples, we used the transformation to graph those. And really, this 3 to the power of x plus 1, you could say that that's a transformation of 3 to the power of x, because we have this plus 1 on the inside of the function, and when we have a number on the inside of the function, that means we can go left or right. Because it's on the inside, we do the opposite. So this would be going left 1 unit of that original function of 3 to the power of x. But I think that we get a nice picture if we just do an xy chart, and a lot of times it saves us some time. When I draw an xy chart, I choose the values of -1, 0, and 1 for x. Sometimes you're going to have to choose more than that, but that's usually what I start out with. So all we're doing is putting these values in place for x. So for the first one, I'm going to be saying 3 to the power of -1 plus 1. So that -1 was my x value that I'm plugging in. -1 plus 1 is 0. Anything to the 0 power is 1. Now to go to my next, plug in my next x value in, I can just press the up key and then it takes me back to what I just entered in. And I can move that cursor around and I can change the number from a -1 to a 0. I do need to delete out that negative, and I did it by pushing the delete key. And now the cursor is blinking over the 1, so I can type in 0 and it changes that for me. 0 plus 1 is 1, and 3 to the first power is 3. Now press the up key again and change the 0 to a +1, and I get 9. So I'm going to plot these points really quickly. We have a -1, 1, which is right here, a 0 up 3, and a -1, a +1, 9. I can see that as I'm going to the right, those y values are getting huge, and vice versa. As you're going to the left, the y values are getting much smaller. It'd be interesting to see, I don't know, let's go left one more unit and see what happens. -2. I know what's going to happen. It's going to approach 0. I'm going to type that cursor up and change that 1 to -2 just to show you what's going on here. Yeah, it gets closer to 0. That's about a third. And if you change the 2 to -3, that's a tenth. Change it to a -4. See, we're getting closer and closer to 0 the further out we go. And there's no need a lot of times to put that many points. But that's the way a lot of these functions are going to go. They're going to have an asymptote. This function's asymptote. An asymptote is where where the axis, where the graph doesn't cross a certain point. And so this particular function would have an asymptote at the graph y equals 0. This function will never cross over that y-axis. Our next example, very similar, more calculator work. F of x equals 3 to the x minus 2 power plus 1. So I do that xy chart. And I plug in -1, 0, and 1. So let me write this down on paper so you can see what I'm doing in the calculator, but it's a base of 3 to the power of x minus 2 plus 1. So I'll be plugging those x values in for x right there. So I start with some parentheses. I'm going to put that 3 to the power of, we're starting off with -1, -1, I'll put that in parentheses as well. Negative 1 minus 2. I'm going to put that 3 to the power in parentheses. And you don't even see my 2, excuse me. I put that 3 to the power in parentheses, and I put the 1 on the outside of the parentheses. So now you can see a really clear picture when I type in the calculator, or what I was talking about earlier, when I said this 1 is on the outside and this one's on the inside. Okay, the one in example number 4 is on the outside, and it's clearly shown by me putting that 1 on the outside of those parentheses as we're typing it in the calculator. So I got my template here. Okay, this is 1.0, I want to say 0.4. I'm going to go up, change that negative 1 to a 0, so I delete out the negative, put the cursor over 1, and type in a 0 and press enter. So 1 and about a tenth. Put that cursor up there. And I'm going to type in 1, and this is 1 and a third. Now these numbers aren't very far from each other, so I'm going to plot them real quick, but then we're probably going to have to plot some more down. So this is negative 1. 1.04 is almost at 1, so I'm just going to put it at 1, 1. Excuse me, negative 1, 1. And then 0 and 1 and a tenth is slightly above 1. And then 1, 1 and a third is slightly above that last point. So I am going to have to choose some more x's because this isn't a clear enough picture for me. I'm going to keep going. Since those y's were getting larger, I'm going to make those x's larger and see if the y's still grow. So let's change that 1 to a 2. Oh, and look, something prettier already. And now change that x to a 3. We're in business. Let's take a risk and do one more. This number may be too big to plot on our coordinate, but it may not be. No, I can plot 10. Okay, so let's plot these real quick. We have 2, 2, and 3, 4, and 4, 10. And that gives us a beautiful picture of our graph. So in example 5, we have a base of 3 still to the power of negative x. And I'm still going to do that xy chart, and I'm still going to start with negative 1, 0, and 1. Okay, and let me show you on paper really quickly. This is going to be 3 to the negative, then I'm going to put x in, and if I make x negative 1, it's the negative 1 power, which is really 3 to the first, which is really 3, okay? And then I'll type the other 2 in the calculator so that you can see that. 3 to the 0 power is just 1. And then, well, it was the negative 0 power, but it's still 1. Okay? And then 3 raised to the negative positive 1 power. How confusing is that, though? Okay? But this is why. Because we have that negative x right up here, that negative out in front, and then the positive 1 that we're plugging in. So it changes the sign of that exponent, which gives us a third. This looks like it's going to be enough points to plot, enough that they're spread out enough. Negative 1 up 3, 0, 1, and 1 and a third Okay, so we're coming off from this direction and doing something like that. Looks like that asymptote is at y equals 0. Okay, and that y equals e to the x. We still have to do it. Guess what? XY chart. And you know that when I draw an XY chart, I always start off with -1, 0, and 1. This is easy calculator work. I'm going to press second, the light blue key, and the LN key, and that's going to let me choose the exponential key. So I start off with -1, which is I'm going to round that to 0.37, and then I'm going to change it to a 0. Anything to the 0 power is 1. And then I press the up key and change that 0 to a 1. E to the first power is about 2.7. And look, we got enough points to plot. -1 and about a third, 0, 1, and 1 and about 2.7. You're going to really like these last two examples in 5.2 because we're going over compound interest, and this is where we kind of get to use exponentials, put them in a formula, and get to see some really cool application that go along with it. So first, let's talk about what compound interest is and what we're finding from it. So let's read that statement at the top. If you have P dollars that are deposited in an account, so that's what you're starting off with, okay? You're sort of like saving money. If you have P dollars deposited into an account earning a certain amount of interest, okay, at an annual rate. So when we say, hey, you're earning 5% interest, we're going to plug that in to this formula, and that's going to be our rate. It's going to be compounded k times per year. Now this k right here, sometimes you're going to see that and it's going to be an n, just like in this formula right there. Okay, it says n on both of those places. So k and n are interchangeable. And then the amount in the account after t years is given by A. So P is that principal amount that we start off with. That's what goes in front. And then we have R, which is our interest rate. We had to change it to a decimal when we have it in a percentage. A lot of times it's going to say like 9%. We're going to have to change that to decimal format. K is how many times we're compounding per year. If you look down here for K, it gives us a little cheat sheet. If it says annually, that's once, semi-annually is twice, quarterly, just like there's 4 quarters in a dollar, is 4, monthly is 12, and daily is either 360 or 365 given the particular problem. They're usually pretty specific there when they give us something that says daily. Let's start off by looking at problem 1. It says if you invest $8,000 in an account that earns 9% interest, compounded quarterly, how much will you have after 55 years? Well, you're starting off with $8,000. That's principal. That's what we're starting off with. And the rate, the interest rate is 9%. I'm going to change that to 0.09 because remember, if you're changing a percent to a decimal, you take that decimal place and you move it over 2 places to the left. K or N is how many times we're compounded. Quarterly, there's 4 quarters in a dollar, and it even gives us this cheat sheet up here. So K is 4 and T is 55. So let's set this thing up. P times 1 plus R over N raised to the N times T power. So I have 8,000 times 1 plus R is 0.09 divided by 4 raised to the 4 times 55 power. Now watch the way that we put this in the calculator. This will be the most challenging part. A lot of times I see people set that right here up perfectly, set their formula up perfectly and plug things in correctly, but we had to type in the calculator correctly. So watch me. I'm going to type this in parentheses here first and raise it to the 4 times 55 power, because that power is only going to the parentheses. It's not going to the 8,000. So parentheses 1 plus, I'm going to open parentheses again. You can see that I have 2 parentheses open there. I'm going to put that fraction in parentheses, 0.09 divided by 4. Okay, close it. I've closed the parentheses twice because I opened it twice, and now I'll raise that figure to the power of 4 times 55. Now I have to multiply that by 8,000. So we get 1069103. I'm going to round that to cents. So that's going to be $1,069,103.26 after 55 years compounded quarterly with a nice low interest rate there. Okay, in the next example, we have $100 that we're investing for 5 years. Change that percentage to a decimal and make it your rate, 0.12 annually. So just 1, and we have that cheat sheet up here. Annually, K is 1. So I'm going to plug it into this formula that we're given. So principal times 1 plus your rate divided by K raised to the K times time power. So again, putting it in the calculator, we have 1 plus. Remember, I do that middle part first. So 1 plus, I'm opening parentheses for the fraction there. I'm going to close it twice and raise it to the 1 times 5 power. And then I just multiply that figure by 100 to get 176.23.